We will discuss the implementation of a lexical analyzer using a C program. A lexical analyzer, also called a lexer or scanner, is the first phase of a compiler. It processes the source code and converts into sequence of tokens. Each token represents a meaningful unit of a program, such as keyword, identifier, operator, constant, and punctuation symbols. The role of lexical analyzer in compilation: read the source code character by character. It groups character into token. For example, integer is a keyword, sum is an identifier. It removes white space and comments, and finally it passes the token to the syntax analyzer or parser for further processing. This LEX program scans C code and identifies keyword, identifier, constant, operator, and commands. It differentiates keyword from identifiers. Coming to the program, percentage open bracket till the part percentage close bracket going to be a header section. That is percentage open bracket and percentage close bracket. This block contains C code that will be copied into the generated lex.yy.c file. Here hash include studio.h allows use to print tokens. Hash includes string.h used for string comparison. Next, function to identify the keywords. Here is keyword const character word checks if the given word is a keyword. Const character keyword defines an array of C language keywords. The size of keyword or size of keyword index value 0 calculates the number of keywords. In for loop, compares word with each keyword using strcmp. If word matches any keyword, it returns the value 1. Otherwise, it returns the value 0. It is an identifier. Now the edge section is finished. Coming to the definition part, digit 0 to 9. It matches any single digit. For example, 0, 1, 1, 2 up to 9. Letter, it matches any letter. Small letters or capital letters. Identifier, a letter followed by letter or digit. Next, number. It matches a number 1, 2, 3 or floating point numbers. Next, command. It matches multi-line commands. And last one, operator. It matches the operator addition, subtraction, multiplication or logical operators. Next, rules section. ID. If a word matches identified pattern, then calls is keyword yy text to check if it is a keyword. If it is a keyword, it prints the keyword. Otherwise, in the else part, it prints the identifier. Next, number. For example, it matches a number like 1, 2, 3 floating point numbers. Finally, it prints the constant value. Commands. Matches a multi-line commands or matches the single line commands. Finally, it prints the command line. Next, operator. It matches operator like for example, arithmetic operator, addition, subtraction, multiplication and division, logical operator, logical and or. Finally, it prints the operator given in the program. Next, command. It matches a multi-line command or single line command. This line matches a space, tab and a new line. It ignores the white space. In this program, number, command, operator, space, tab, new line, everything we are given. In case if you got some other symbol, it printed in this line. It means matches any character not handled by previous rule. Finally, it print the characters. In the main function, we call YYLEX function. It starts scanning input and return the value 0. The YYWrap function tells LEX to stop scanning at the end of the input and it always returns the value 1. The source file name is clex.l. Now we will execute the program. The commands are lex file name c_lex.l. Then type gcc lex.yy.c space -o lex_output -lfl. Press enter. Then finally you type /lex_output output. Then type the source code. For example, integer a equal to 60. Then press enter. Then you will get which is the keyword, which is the identifier, operator, constant and other symbols. In this line, integer a equal to 60. Here integer is a keyword, identifier a equal operator, constant value 60, semicolon, other symbol. When you write a LEX program, C lex.l, you need to compile and execute it using these three commands: lex space filename.l, gcc space lex.yy.c space -o space lex underscore output space -lfl. Finally, /lex underscore output. Lex. This command runs the LEX compiler. File name C underscore lex.l. This is your LEX source file containing rules to tokenizing input. LEX. This command runs the LEX compiler. File name C underscore lex.l. This is your LEX source file containing rules to tokenizing input. The LEX compiler LEX reads the source file. It generates a C program lex.yy.c which contains code for the scanner automatically generated C file, that is lex.yy.c. GCC calls the GCC compiler to compile lex.yy.c. The lex.yy.c source file generated by lex filename.l. -o lex output created an executable name lex underscore output. -lfl which links the library which contains lex function. Here lex underscore output is your executable file. Finally, /output file lex underscore output. It runs the compiled lex scanner. /. It indicates the current directory. It ensures we run the local file. The scanner starts the reading input from the keyboard or a file. It matches a token based on the rules in a source file C underscore lex.l. It prints the recognized token, keyword, identifier, constant, operator, command. Then type source code integer a equal to 60. In this line, integer is a keyword, a is a identifier, equal is a operator, 60 constant value, semicolon is a other symbol. Here, lexical analyzer is also called as scanner, is the first phase of the compiler. It converts a high-level language into stream of tokens. Each token represents a meaningful unit, smallest unit of individual program, such as keyword, identifier, operator, constant and punctuation symbol. I hope you all understand the implementation of a lexical analyzer using a C program. If you have any doubts, feel free to ask in the comment section. Don't forget to subscribe to my channel for more videos. Thank you.